بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله. كل عام وأنتم بخير وعيد مبارك. My name is Mustafa Shu'ala. The title of my project today is Arabic Handstock. Arabic Handstock الأيادي العربية تتكلم. In computer vision, I work with my colleagues Abdul Karim and Muhammad to translate Arabic sign language using a computer vision technique which is SIFT, by extracting features. Today I'm going to recognize and translate Arabic sign language using a deep learning technique which is YOLO. In my presentation, after stating my problem, I'm going to go through the methodology and the evaluation measures that I'm going to use in the experiment. Then I will talk about how I initiated a new data set from zero, how I initiated and labeled new data set, which is really I spent significant amount of time just labeling the data sets. That shows me really how tough labeling is. It's not easy job. Then I will go through the experiment and show the result and conclude my presentations with the challenges and future work as a wish list. According to the World Health Organization, around 5% of world population, they are suffering from disabling hearing loss. The number, it's almost 400 or more than 400 million adults and 32 million children. In 2050, it's expected that this number will be doubled. It will reach to 700 million individuals suffering from disabling hearing loss. 25% from the deaf community in the world comes from Arab world, and this shows how important it is to come up with intelligent, smart solutions to help deaf people to hear us, we understand them, to bridge the gap between us as normal people and deaf people. This brings me to the problem statement: can Arabic Sign Language be recognized and translated using deep learning technique, and more specifically deep learning object recognition technologies like YOLO? So what's YOLO? Before we talk about YOLO, so the methodology that I'm going to use, I have video of frames or images with sign signatures or hand signatures. I'm going to feed it with a trained YOLO model, and the output is detected hand signature gestures with a translated word. Like as you can see here in the picture, I'm doing Assalamu alaikum. I want a rectangular with Assalamu alaikum on the top. Okay. So what is YOLO? YOLO is, as we learned from Dr. Irfan, is the fastest general purpose object recognition technique, deep learning technique, that divides the input image into grids, like let's say S by S grids. In each cell, we calculate the confidence or the probability of having an object of interest in that cell, or the center of that object in that cell. So then the final detections is just a rectangular box around that object of interest. YOLO shows really excellent scores compared with other object recognition. And as you can see here in the recall position chart, YOLO is really high. It reached the human's point. Yeah. It has 24. It's CNN architecture. It has 24 layers, ended with 2 fully connected layers, and there is alternating one-to-one convolutional layer to reduce the features space. The latest version of YOLO is 5. As you can see the image in the bottom, it shows more objects. It has higher resolution. You can see here in the yellow boxes, it detects the traffic lights in the back end, so it's more powerful. It has the regular model architecture, which is single stage object detector. Sorry. And in terms of activation function, they use for hidden layers leaky, relo, and for the output layer sigmoid. In terms of optimization, they use SGD and ADAM. They provide 5 models, terms small, medium, large, and X large. It's like the clothes. It depends on you, the problem, the domain of your problem. Also, the capability of your computation. For example, in my case, I couldn't exceed S to M. It's almost, I cannot go to large. I tested large, I was out of memory. Even if I paid to Google Colab, but it's still, this is not meant for cloud computation. It's for powerful local GPU. So, however, S and M, it's really powerful, and it gives very good result. In terms of evaluation measures, I'm going to use the precision, recall, and F1. As you know, precision, it measures how accurate your prediction is. Where recall, it finds how good you are in predicting all the positives. F1, it's the ratio between the two, and MAB means means average precision. And this is used by YOLO as a measure, as accuracy measure. Also, I'm going to use confusion matrix. Confusion matrix, it's really a powerful and nice evaluation window, because we can see all the misclassifications in one window. Okay, now data set. I decided to use or to collect the Arabic greetings. I did it from scratch. I recorded the videos, then I moved it to frames. I did it like divided into frames, like around 4,000 frames. I labeled around 764 labels, and it's really, I couldn't continue more than this, because I spent more than one day just labeling, and I still have pain on my right hand, because it's really tough, because it involves a lot of clicks. However, the data size is 1.77 gigabyte. The labels, or my classes, it's Assalamu alaikum, marhaba, sabah al khair, shukran, afwan, ahlan wa sahlan, ma'a salama. 8 Arabic greetings. I use a labeling tool, which makes sense here. It's a web-based JavaScript tool that helps you to label. There are other tools, but I found this very convenient, easy to use, easy to upload, easy to get the labels. So here the classes, class 1, Assalamu alaikum, like this, and ahlan wa sahlan, shukran, afwan, marhaba, كيف حالك, and مع السلامة. Here صباح الخير is a bit complicated because it requires 2 parts, like صباح الخير, صباح الخير. Okay, now ready for the experiment. First, we open the official notebook of YOLO, which is available in either Colab. You can open Colab or Kaggle. In my case, I use Colab. We need then to get the clone from GitHub. Sorry. And this is very important. You configure the data set. They have YOLO. They have a special format. It's called YAML, where you should store or you specify where your data is. So here I specified my train, my validation, and the number of classes and class names. Here the structure of the data sets by YOLO. It contains of 2 subfolders, images and labels. And images has also 2 subfolders, a train and val. In labels, and each image has a corresponding label text file with the same name. And the format of the label, the first digit corresponds to the index of that class, and X, Y, and the other information is for the rectangular box. here it's x, y coordinates and the height and width of that box. Okay, now ready for the training. We use the train provided by YOLO. Now we have the image is just the input size is 640 by 640. The patch here it's 32. I try to use more to improve the results, but I get out of memory because it really requires a lot of memory here. So I left it for 32, which is good. It gave me good results. A box is 100, and the data is custom data where I specified where my data is, and I use the pre-trained weights from YOLO, and that's the model. It has around 7 million parameters. And here is the prediction, the result while training, and it gave me really good results. Like here, صباح الخير, أهلا وسهلا, all good. This is batch 0, batch 1. Also here مرحبا and السلام عليكم, all predicted correctly. Here the result, the recall, it shows around 90%, precision 64, and the MAP, the means average precision, it's almost 75%. It goes from 75 to 85. It depends on the run. This is the precision and recall curve. It shows the classes in details. Like F1. F1 it's a symbol to predict. It's like only this. It's a very static gesture. It gave 99%. And here the bold one shows the overall MAP. Okay, now confusion matrix. As you can see here, it shows very good results. Here there is some misclassification, like Assalamu alaikum and Marhaba. As I said, some signs they share some gestures, like Assalamu alaikum. It starts with this, then you shake hand, Assalamu alaikum. While Marhaba is like this. So it's the beginning, it has the same motion, which leads to misclassification. However, I don't see this is very bad because it doesn't deviate the meaning, because Marhaba and Assalamu alaikum almost have the same meaning. Also, Assalamu alaikum can be detected easily after the first gestures. When you shake hand, the system easily can detect the gestures afterward. Okay, here there is some مع السلامة, and the background fall negative, and I think this is because of occlusions. The hand was out of the camera. Okay, challenges. The most challenging part in my experiment is the data and labeling data. I compare it with other languages like English. We are here in Arabic language way behind, and we really need a lot of efforts to come up with more data, labeled data, so we can be able to use them in such deep learning solutions. It's more than 80% efforts goes to the data and collecting data. Also, motion detection. Motion detection. This is a very important assumption, by the way, because my work is based on assumption of static gestures. Like I have this very static. I can map this to a class, which is Afwan. However, this is not always correct with the Arabic Sign Language, because some Arabic words, it requires a lot of complicated motions. So we need to add the third dimension and track the motion of the gestures. And this is another work need to be investigated. Also, adding another like technology, like converting words to voice. I think we can integrate this with the deep learning system to come up with a more convenient and appealing solution for the user. last but not least, the system I come up, it's dependent system because it's based on one signer, but in reality we need to test it with more signers. I asked my son Ahmed to test it with me. It gave me good result, but it's not that accurate because we need the training to test with different signers to come up with a signer independent system. By this, I'm done with my presentation. Thank you so much for hearing, and I will leave you with the demo. Have a good day. Bye bye.